welcome back to my channel. So today let's discuss the problem maximum number of K-divisible components. I have attached the problem link and the solution link in the description. You can go and you can check out. And I have added a Leetcode extension where you can see the company tags. And without wasting any further time, let's understand the problem statement. There is an undirected tree with n nodes labeled from 0 to n minus 1, and you are given an integer n and a 2D integer array edges of length n minus 1, where edges of I is indicates that there is an edge between A and B. He is saying that he will given edges and AI BI, and there is an edge between both these. And you are also given 0 index integer array values. For every index we have some value, where value is the value associated with the node and an integer k. A valid split of tree is obtained by removing any set of edges possibly empty from the tree, such that the resulting components of all values must be divisible by k. He is saying that, suppose let's take this example. We have 6 and we have 6, and here we can take 4 and we can take 2. If you take like this, and if the value k, suppose it is 6, then how we can break down? Either we can break down the tree here or here. If you see, this 6 is divisible by k, and this 6 and this 6. Total how many components we are able to form? 3. So we need to return the 3. So we need to return the maximum number of components. So we have to return the maximum number of components. And if you observe this, you can observe this. This is the constructed tree, and this is also constructed tree. Now I have written the values. He is saying that k is equals to 6. K is equals to 6. Now if you break down the tree here, this is 6 percentile 6 is 0, and if you break down the tree here, this is 12 percentile 6 is also 0. And in the constant you can see that the input generated such that edges represent a valid tree, and the sum of values is divisible by k, and we should not care about that because all the sum is divisible by k. If there is no answer exists, we can get all the only one component we can form, we can return in that way as well. And if you observe this, k is equals to 3, we can break down over here, and we can break down here. It is 9 and it will be 6 and it will be 3. Total number of components are 3. Okay, I got this. After saying this, we got little bit of idea about the question. Now if you see, suppose if I have it just like this, 3, and here I have 4, and here I have 2. Now I am taking k as 3. So suppose you can include complete component. This is divisible by 6, we will get the sum 9. Or else we can break down here, so that 3 can become an independent part. Okay, if 3 is becoming independent part, is this dependent on this nodes? If 3, and there is like so many, here you can find different elements, but is 3 dependent on this? No, because this 3 is divisible by 4 and there are no dependent elements for 3, so we can directly remove it. So first thing we will do is that we will take all the leaf elements which are divisible by k, Suppose you have elements, and sorry for that. Suppose k is 4 and our elements are, let's take 8 and 4 and 3, 1, 2 and 2. If you take like this, now we are at leaf nodes. 8, 4 and 2 are my leaf nodes. 8 is divisible by 4, yes, so I will take 8. Now I will check 4 is divisible by 4, yes, yeah, so I will break down this here, I will break down this here. Now we have 3 this left. Now my total components are 2. Now, is this 2 is divisible by 4? No. So Ayush, what we can do? If this is not divisible by 2, then can we give this to our parent? Can we give this to our parent? Absolutely. Absolutely we can give this to our parent. If we give this to our parent, we can decrease the in degree and we can remove this value. Now with this point we got 4. Okay. Now here we will decrease the in degree. Now here the in degree will be 2 because 2 nodes are there. Now this in degree we will decrease. Now we have 4. 4 is divisible for, absolutely it is divisible by 4. So I will increment the count 1 plus. Then it will come over here 1. This is my leaf node. Okay, this is my leaf node. It will come to, it will check whether it is divisible by 4. No. So it will come to 3. It will come to 3 and it will see, okay, this 3. This 3 is divisible. I will add this 3. It will 3 plus 1 4. 4. Yes, these two are already detected from this, so I will not consider that. 3 is 4 percentile 4 0. Yeah. So I got the answer as 4. So what exactly I will do? If my in degree is 1, in degree 1 or 0. If it say that if n is equals to 1, there is only one component. Suppose that is 36. You can't detach, right? If in degree is 0 or 1. If first we will calculate all the in degrees. If it is 0 or 1, we will push into the queue. We will push into the queue in the same way which we have done here. We will push all the in degrees 4 1 4. So my queue will be 4 4 1 and 4. 4 1 and 4. Now this 4 I will check. Now in the code, if you see, I have inserted it. I should copy. Can copy this so that it will be easily understandable. Now we got this 4 1 4 is in my first queue. Let's take q1 4 1 4. Now at 4 my k is 6. My k is 6. I will check if 4 percentile 6 is 0. No, right? It is not 0. So I will go to its parent. I will go to its parent. This is my parent, and this in degree should not be equals to 0. Should not be equals to 0. That means it's not visited. It is not visited because when we visit 4, we are making in degree of 4 as 0, so that it can't be visited. We are not using extra space. We can use visited as well, because we can use that. I am not using, I am just modifying the in degree. So if it is 0, we will not visit. If not, it is not equal to 0. Now this in degree is 3. In degree is 3. We will decrease the in degree to 2 because we are detaching it. And we are adding the value. Now here plus 4 is added. Now you will come to 1. This 4 we are popped it. We have popped from the queue. Now we are at 1. And we are checking whether it's divisible. It's not divisible, and its parent is this. It is also not divisible. We are decrementing it, and we are adding 1 to this. And we are minusing it. And in q2 we are inserting this index, this one index. So it will be 1. Now my 4 is left. Okay. Now 4 is divisible by k? No, right? So we will decrease the in degree of his parent. Right now this in degree is 2. We will make it as 1, and we will add 4 to this. Here we added plus 4, and this in degree is 1. If it is 1, I am adding. If it is 1, I am adding. Now I got 8. Now for this we have added 4 plus 1. For 8 we have added 4. So if we do next value of if percentile k is equals to 0, for this it will be 1 and this will be 1. So my final answer would be 2. I think you have understood it. Like why I am considering only in degree of I is equals to 1. Suppose you have notes like this. When it is decreasing, when it is coming, suppose this in degree will be 2. Let's consider this in degree as 2. Now we are detecting it to 1, and we are adding it into the queue. and suppose it is coming from this side. Now this integer will be 0 because I want to add some to this root node. This will be 0, but it is already in the queue. So I need not to add. That's why when int degree is 1, I am adding. When int degree is 0, because it's already in the queue, I am not adding. So I think you have got this solution. And what will be my time complexity? We are iterating to the every node and we are checking. So it will be order of number of edges plus number of nodes, and my space will be same, number of edges plus number of nodes. I hope you understood this solution. If you understand this solution, please do subscribe to my channel, and thank you for watching.